All right. So there's a bug in our code, right? When we got to it last time, we saw that Python detected the fact that we exceeded 1,000 times in recursion, and that's probably a bad thing, right? Maybe we would have resolved an answer in 1,020 times, but in 1,019 we didn't, and it cut us off. So the bug here is ridiculously simple, but it doesn't mean it's easy to find. And so how do we debug in recursion? Well, my rule of thumb is if I'm doing something recursively, I just start, and this is actually probably true of most solutions, but I just start by printing out what I was passed in. You might now want to print out literally everything because the instruction list might start to get big, but let's just see what happens here. Oh wow! And I'm gonna hit over here Control C. Oop, control. No, it's not. Nope, it's not letting me break out of it. So I definitely have something wrong here. And normally you can Control C. Oh, there you go. Finally, it caught up to my Control C keyboard interrupt. Um, so let's see what's going on here. So I got recursive 3, recursive 2, recursive 1, recursive 0, -1, -2, -3. So I keep coming in. So I don't seem to be actually stopping when I get to my base case. So it would seem if I follow it in. So let's think about this. I'm moving A to B. I'm sorry, A to C via B. That's the first one. From starting point to destination using this as a support post. That's the first call. That's exactly what we expected from before, right? So if I go back to here, I'm moving 3 to moving 3 from the starting post to destination post using the support post, right? And then immediately after that, I'm moving 2 to the support post from the start post to the support post via the destination post, right? That makes sense. And then I'm moving 1 from the let's see, C is the destination post to from the start post to the destination post using the B in the middle, and so that's what this gets printed out here, the base case. That's what gets added in. So this is the base case, but it seems to keep re-going after the base case. So why? Um, well, let's let's explore it more. So I'm going to close this to get me some space. If you don't see it yet, which it's actually quite simple, but you might not see it yet. What we can always do is, you know, not the base case, and we can add inside of here base case. And you know what I'm going to do just to make my life a little bit easier, because I'm going to think ahead a little bit and put in the current disk I'm working on so I can tell which version of the recursion I'm dealing with. So if you just put a print statement, you can't always tell which recursive step you're in, or at least you have to do it. You have to watch, the start and end of these. So I'm going to put that in to maybe help me a little bit proactive thinking. So let me run this one again, and I'm going to be ready with Command C to kill it because I expect it's going to, oop, yes. So I hit it right away. So I expected it was going to do that. So let's see. So 3 comes in is not the base case. 2 comes in is not the base case. 1 comes in and it is the base case, but it's also not the base case. And then 0 comes in, it's not the base case, and then they're all not the base case after that. Because it's only the base case when it's equal to 1. So I am arriving at the base case, but it's not stopping at the base case. And so if you don't see it yet, the answer, again, is deceptively simple. And it's also a little warning here about how recursion can go. In most cases, a recursive function simply returns something. Like we saw before, when I have a factorial, I return the base case number. I return the answer for me. I return the answer. In this case, that's not the pattern we're following. I could maybe simplify this a little bit by not creating a list of instructions, but by printing them out. But then this function's only useful when I want to print out instructions too. a screen. I couldn't use this to build instructions for a website, for example. So that's why I want to be able to create these instructions, pass them along. Now I can't return instructions. I could return instructions theoretically, but then I would be creating appending strings on top of strings on top of strings, and it can be done, but that's not the way I chose to do this. I wanted to create a list of instructions because then I can show them one at a time instead of having one big string. So that made sense as well. And so if I return a list, I could, but there's nothing to stop me from just returning in general. So let me put this in here, return, right? So if it's the base case, I need to stop out of here. The other thing I could have done, there's another thing I could have done instead of this. I could also just do else. So a good rule of thumb is when you use an if statement, you should always consider what the else branch is. So it either should have an else branch, have a return statement to avoid the need for an else branch, or you should account for that else branch, which might be saying, oh, there's no else. So, for example, if it's raining outside, I'll take an umbrella. If it's not raining, there's no default. I don't take sunscreen just because it's not raining outside, because it could be snowing outside. It could just be cloudy outside or whatever. So that's either one of these could work. Let me try this one, see how it goes. Yes, I not only um, stopped the overall failure, I'm also passing the test. So again, this works. Or if you wanted to, and you don't prefer the else branch inside of there, you could just say return. I'm a fan of return in that else works because there's only 3 lines of code. Otherwise, I'm a fan of return because it just says, okay, these are the exception cases, and then I write the code below and it ignores that. We just never even get to the other code because of it. But it's easy to forget it, which I did. So I could make the argument that the else is better. Um, so in general, though, my rule would be if you have an if statement, consider is it supposed to do something else, or just are you done at that point? Or is it okay to do just one thing? So let me clean up my last bits of code by taking out my print statements, run it one more time, and look at that. Oops, I have one more print statement there. Sorry. One more print statement to take out, and all my tests passed. If you wanted to see it, you can certainly print it out, but before you submit it, you should probably take out your print statements. But we can see our solution is we move disk 1 from A to C, move disk 2 from A to B, move disk 1 from C to B, move disk 3 from A to C, move disk 1 from B to A, move disk 2 from B to C, and move disk 1 from A to C. And that's our three solutions. If you want to play with more, you can see more, and it'll continue to work for bigger amounts. But that is, in short, your Tower of Hanoi problem. And I hope that you maybe saw some cool little approaches to solving problems here and can use this in being a better programmer going forward.